All right, I'll get started with the introduction real quick. So, hi everyone, thank you for coming today. My name is Grace Collars, and I'm an AmeriCorps member at Conservation Nebraska, and I'll be your host for tonight's event. My fellow AmeriCorps member, Julissa, plans tonight's event, so I'll be here for the technology side of things. I would like to start off reminding everyone your cameras are turned off and you're automatically muted. So if you have any questions during the presentation, you can drop them in the chat or the Q&A function. And there will be a poll sent out at the start and the end of the presentation. So if you complete both polls, you'll be entered twice to win a $25 gift card. And if you complete one, your name will be entered once. And then while Julissa introduces our speakers for tonight, I'll release the first poll. Both polls shouldn't take too long at all, and they help us with planning our future events and our grants, just so we can get an idea of our community members' knowledge and what they would like to know. So, Julissa, you can take away with the interest.
All right. Well, hi everyone. I'm Julissa. So for today we have two speakers from OPPD, which is Michael Lausevy and Justin Weimer. So Michael is the Alternative Energy Specialist at OPPD. His work includes supporting OPPD's alternative energy projects and analyzing the alternative energy landscape as it pertains to industry trends and emerging technologies. Michael has also been an employee of OPPD for almost 14 years, and prior to joining the Alternative Energy Program, he spent 11 years at OPPD's Fort Calhoun Nuclear Station. He also holds a Bachelor of Science in Biochemistry from the University of Nebraska-Lincoln and a Master's of Engineering in Mechanical Engineering from Iowa State University. And our other speaker is Justin Weimer, and he's the supervisor of peaking station operations for Omaha Public Power District's fleet of 9 combustion turbines. And prior to leading the peaking stations, he was a system engineer and senior reactor operator at OPPD's decommissioned Fort Calhoun Nuclear Station. And he is a licensed mechanical professional engineer in the state of Nebraska. And yeah, now I'll hand it off to you guys.
All right, well, I will kick it off. If I can get it to move. There we go. So here's kind of an overview of what we've got on deck for you today. So general OPPD overview, what we are as a public power district. Next up, you'll hear a lot of information from Mike on kind of the general landfill gas process. And then I will close it out with how we utilize that gas, what equipment OPPD owns. So OPPD, also our formal name will be Omaha Public Power District. We're the 12th largest public power utility in the US based on customers served. And overall, we are 9 to 16% below the national average in rates for all the various customer classes. Our vision is to leading the way, we power the future. We do that by providing affordable, reliable, and environmentally sensitive energy services to our customer owners. And our core values are we have a passion to serve, honor our community, and we care about each other. So I won't go through all the specific numbers here, but you can see we serve the 13 counties that are in and around Omaha, as well as then to the south, kind of going up against the Missouri River. Note that number of 2,691 megawatts of generation capacity, because 6 of those will be specifically the landfill generation that we're going to go into detail on. So how we serve, very diverse mix of fuels and natural resources. We have 2 baseload generating stations, the North Omaha Station and Nebraska City Station. Renewable energy accounts for nearly 40% of our total generation. and that's wind, solar, landfill gas, hydropower. And you can see on the graph what that trend has been. So Nebraska is really special compared to the rest of the nation. We're the only state that is 100% public power. So that gets you a lot of benefits for us being customer owned. So you have local control. We have a locally elected board of directors. It gives you affordability and reliability that's all directed via our customer owners through the board of directors. And you can see on that map, exactly where we're at in kind of totals for various public power districts. And I guess that's it for my summary. Mike, you're up for landfill gas generation and capture.
Sure. Thanks, Justin. Can you guys all hear me? Hear me okay? Okay, cool. All right. Yeah, so I'm going to jump in kind of like Justin said and talk about kind of how the landfill gas, and I know this is kind of focused on methane, but that's a piece of landfill gas, and kind of how we collect it and then how we kind of refine it before Justin kind of talks about how we use it. So go ahead and click the next slide. We'll start in. Okay. Okay, so again, methane is a piece of this landfill gas, and kind of the first thing we need to talk about is what is landfill gas, or LFG. So landfill gas is basically the natural byproduct of the decomposition of organic materials, organic being something with carbon in it, at landfills. So when you send your trash to the garbage truck and the garbage truck takes it out to the landfill, you probably have materials in there that have some kind of carbon in them. Plant-based, food-based, even manufactured materials have carbon in them. When it gets out there, it starts decomposing, and we'll kind of talk about that here in a second, what that looks like. But as it decomposes, it lets off this gas, and that's, again, landfill gas. It typically contains, you can look at the pie chart, about 50 to 55% of methane, which is an organic energy-containing molecule that's really important here for this generation. And then 45 to 50% carbon dioxide with a bunch of other little things, and you can read them on there: ammonia, oxygen, sulfides, hydrogen, carbon, and non-methane organic compounds. So most of this landfill gas, or LFG, is carbon dioxide and methane, and that's an important concept moving forward. Go ahead to the next one, Justin. All right, so this chart here, we're going to go through, there's basically 4 phases of generation of gas as materials decompose. And that chart over there on the right, you can see the 4 phases. We'll kind of talk about them briefly, just so you can kind of get an idea of what's happening. So phase 1 is an aerobic phase. Aerobic means where there's oxygen present. Bacteria that's present in the materials out there at the landfill will consume that oxygen, as well as break down these chains of complex carbohydrates, proteins, and lipids. So big, long chains of carbon-containing materials, they eat those, use the oxygen as fuel basically for them. And you can see in this graph, and I can't really, Justin, you're going to have to help me out, but you can see the nitrogen content, that's the dotted line up at the top. It's starting at like 80%. As those bacteria work and eat, they basically take that down 30% based on that chart, but they eat, the nitrogen is leaving. Oxygen as well is leaving that down there at the bottom. That's really important. As we'll get to the next phase, or 2 phases from now, you can't produce methane through these processes while there's oxygen present. Phase 2 is where we start the anaerobic phase. So anaerobic meaning no oxygen present. All the oxygen's gone. I know it shows a little bit on that chart maybe, but basically all the oxygen's been eaten up by these bacteria. And now these anaerobic bacteria, they go in and convert all the byproducts from that first phase into these acids. And they're just a bunch of organic acids, formic acids, and maybe some methanol and ethanol. But an important thing to look at in phase 2 is the carbon dioxide starts going up. So byproducts of phase 2 are these carbon dioxide molecules as well as hydrogen, and then the acids, which not important for what we're talking about today. Go ahead, next slide. Phase 3 is the important phase for what we're going to talk about today. So phase 3 is where methane starts to be generated. And you can see that in the green line on the chart over there. So phase 3 uses the previous phase 2 materials, and they form acetate or acetic acid and methane. And methane, like I said before, is kind of the main energy containing molecule that will be used by our processes, and that's kind of the one that we're looking for. And as you can see, nitrogen's continuing to go down, carbon dioxide's kind of peaked and come down, but methane is coming up at a strong rate there. The phase 4 is basically once the landfill has hit this steady state. They call it the methanogenic steady state. Not an important term, but basically we have all this gas coming out of the landfill. It's filled with methane and CO2, and we can use that. So let's go to the next slide, Justin. So there's a bunch of factors that affect the production, as you can probably guess. So temperature of the landfill, it's going to increase bacteria activity as it grows, like many other processes. Moisture being there, it encourages the decomposition. Presence of oxygen, we kind of just went over that. You don't want oxygen there, so we need that oxygen gone before we can get methane. The age of the materials that are in the landfill, usually stuff that's more recent is better to produce gas, or we produce more kind of at the beginning. And then the composition, which is huge in any kind of biogas or landfill gas, the composition of what's in there, you need organic waste, so something with carbon in it. So that picture over there is kind of cool. It's a wellhead, which I've got a schematic later. But basically the capped landfill, it's got this material over it. You can see some plant growth. This is a capped landfill, and they will vertically drill these wells, and they look like this. I think a lot of them are made out of PVC, and you got some corrugated piping there. But basically, that's what's doing the work of collecting that gas that's pouring down below in the landfill material. But we'll get to that in a second. Let's go to the next slide. So methane, I've been mentioning methane. That's I think was one of the focuses of this talk. But methane is really the energy molecule. It's chemical composition is CH4. It's a carbon with 4 hydrogens around it. It's a gas that's basically it's natural gas. I mean, it's natural gas is mostly methane with some other stuff in it. This is kind of similar. So like we said, this is about 55% methane. It is a greenhouse gas. I don't know, a lot of people think about methane as a greenhouse gas, but it is. It's the second most abundant greenhouse gas over CO2. I think CO2 is most of the headlines you see, but methane is also out there, and that last bullet is important. And again, I don't think a lot of people realize that methane is more than 25 times as potent as CO2 at trapping heat. So a large contributor to potential climate change and any of those aspects that you think about with greenhouse gases. The pie chart on the right, it's 2020 U.S. methane emissions. You got natural gas and petroleum systems at the top. You've got enteric fermentation, which is basically like cattle, livestock production of methane, and then landfills. So landfills, that 17%, what we're doing here with Elk City, and we'll talk about in more detail here, but we're capturing that methane so it doesn't go to the atmosphere, and we're using it to produce energy. Let's go to the next slide, Justin. All right, so this is the picture of that wellhead. It's kind of a schematic. It's I don't know if it's hard to read, but you can kind of see the vegetation if you start at the top and looking at the picture. Working your way down, you got the topsoil, the cover, basically it's capped landfill, and then you get down into the materials that are down in there, the waste materials. And you can kind of see that pipe, and it's like PVC, and then it's kind of got holes in it, like, at the bottom. And what happens is that gas, as it's produced in that waste materials, it's pulled into this pipe or this vertical wellhead or well. We have blowers and vacuum systems potentially downstream that pull that the gas basically out. It kind of just seeps out of this wellhead. It's not a very complex process when you're out in the landfill, for sure. So yeah, this is basically the most common way. There's other ways where they horizontally drill in, and the vertical is pretty much what you'll see. And just for info, our Elk City Station currently has 108 of those extraction wells out there. So let's go next. All right, so we we kind of talked about how we generate it. It's generated through all the processes with the bacteria. We talked about collecting it. Well, you have to process it because the landfill gas coming out of there is pretty moisture rich, I would say, and then it's also got impurities in there that we don't want to burn or use in our processes. So the schematic at the left is kind of detailed, and I'm not going to go through everything, but that picture on the right is really kind of a good representation of what this cleanup system skid or whatever you want to call it would look like. So you've got a knockout drum, which is that tall thing. It's going to kind of have baffles in there that helps filter out that moisture. You've got blowers that provide the vacuum to pull the gas kind of throughout the system. You've got the flare that will off gas and burn parts that we don't want. And then this we use it to clean it up before we use it in our machinery, because any of those materials are stuff that we don't want. Elk City, it has the blowers and vacuums that they can go at a rate of 1,100 cubic feet per minute. If you look back at the green thing, and I know I'm kind of skipping around, but that skid basically does that top part up there, the top left corner. And then I guess it would kind of do part of that second part. Some of the impurities are removed. And then you can take it out to, I don't really know what the arts and crafts piece is. So, but you can use it for electricity generation at that point. You really don't have to clean it up anymore. The advanced treatment down at the bottom, you can actually convert landfill gas into basically, they call it like biomethane. It's basically identical to natural gas, and then they can use it in vehicles or pipeline injection. But for our needs, for Elk City, you don't have to refine it that far. Our machinery can use it after that initial primary treatment and secondary treatment. So that may be all I have, Justin. Looks like they're turning the lights off on you out there.
Yeah, I'm not in my normal office, so evidently this one has the little motion sensors, and I hadn't moved enough.
Perfect. All right, yeah, go to the next slide. I think you take over from here. Yep.
All right, so once you pull this gas from the landfill, we then want to use it to create a product or electricity that we can then provide to our customer owners. So Elk City, as we know it, was built in two different phases. First one was in 2002, and the second phase was in 2006. This is all done with a partnership with Waste Management. So they operate the landfills and they own the landfills. And this facility is one of the best facilities in the district in terms of availability and capacity. You don't commonly hear base load renewable generation, but this is one of those cases. It routinely operates at a 90+% capacity factor. So here's just an overview for where we physically sit. So if you look at that on the left, you can see the larger landfill, and then we're in that little cutout that you see on the picture on the right. And then there's well and gas transport infrastructure kind of throughout the facility. So these are what the engines are. We have 8 Caterpillar engines, roughly 800 kilowatts apiece. So if you think through what a portable home generator might be that you could pick up at Menards, that's probably in the 5 kilowatt, maybe 10 kilowatt range. If you bought a large one, this is 800 kilowatts. One really interesting thing about this is normally when you think of a diesel generator, it uses compression ignition. Given the quality of this gas and the methane content of it, we actually have to use a spark plug for these to operate. So they are a little modified compared to an off-the-shelf Caterpillar engine. So if you look at these pictures, I'll kind of stop and talk a little bit about how they're set up. So the closest to you, that's the actual generator. And then the engine sits further back. Can you guys see my mouse coming through, or does that? Okay, good. So you bring in air through these air filters. There's another one on this side. And then it goes in through a turbocharger. It's injecting the the methane gas through one of those pipes. And so you combine air with that methane, send it in, you combust it through the reciprocating engines. On this, you can see a good shot of the head. And just like any other engine that you've got, you need to be able to cool these. So for reciprocating engines, they use a phrase called jacket water. It's basically a radiator setup. And if I go back one, you could see all of the radiators here. And then you can see the exhaust stack where it goes up. And overall, this site is entirely operated and maintained by Waste Management. So they have 2 or 3 technicians that they are out there every weekday doing routine maintenance or forced outage maintenance if something went wrong. They have an on-call system, so if one of the engine goes down on like Saturday morning at 3 a.m. for some unknown reason, it calls them out. Overall, it's just a very good facility, and we've been reinvesting in it continuously over the last 20 years or so. And so at this point, I'll open it up for questions. One answer that I don't think we got to directly in Mike's presentation, but I'll tie it back to your initial pre-lecture question. There is sufficient landfill gas to operate this in excess of the year 2100. So that is the answer to that one.
Looks like we got one question, Justin, so far about
Okay.
how much methane is not captured and how much is flared. A great question.
So Mike, do you want me to take this because I've been there for operation of it?
Deal. I do, because I don't know the answer. I'd like to know.
Okay. So let's see. David's the one that asked this. David, I don't have an exact number like so many cubic feet per minute that's flared off. Essentially, the air permit for the landfill, it's owned by Waste Management. So anything that is not consumed by these engines must be flared off. So you will always see a flare there. As long as these engines are in service, you'll notice that that flare is a lot dimmer. Just from the times I've been out there, I can tell you if the whole plant tripped off because we had a storm or something roll through, you could definitely see that flare being significantly brighter. I hope I helped with that. I know I couldn't answer the question fully. What's the other one? Do you use another power source in this area, or does the methane gas cover the power for the whole area? So let me go back to one of the early slides. So this is the OPPD service territory. The total generating capacity of Elk City is roughly 6.4 megawatts. If you look at the larger OPPD footprint, our load is going to be somewhere between, say, 1,000 megawatts on kind of a really nice day, you know, sunny, 70 degrees in April. Pick a day when there's no air conditioner, kind of limited industrial use, to a hot summer day like what we've been experiencing plenty of already. And, you know, that would get you into the 2,400 to 2,500 megawatt range. And I don't have the exact peak load for OPPD handy, but it's in that neighborhood of 2,500 megawatts. So we will always cover our load within OPPD. That could be using any of the power plants that we have, or even purchasing off the market, or our purchase power agreements with several wind farms, which are all throughout the state of Nebraska, not necessarily inside OPPD service territory.
I guess there's a couple more in the Q&A section. Lori asks, is the gas coming from Pheasant Point or the old landfill or both?
So Lori, it's coming from both. The old landfill, or the Douglas County landfill, that is kind of ramped up in that methane production range. You know, thinking back to those graphs Mike was showing earlier in the presentation. Pheasant Point's still active. So Pheasant Point's kind of earlier on that curve. And that's what gives you that 2100 plus, is between both of those landfills. You know, as the old landfill starts to really taper off, you'll see the new landfill, meaning Pheasant Point, ramping up.
All right, and then Peggy asks where Elk City is.
So it's right next to that landfill. Let's see, does the see if I can guide with. So, you know, here's Bennington, if you can picture that over on the right hand side. So if you just drive Highway 36 and go past Highway 31, so 31 goes north and south here, 36 goes east and west. It's about a mile from that intersection. Then Elkhorn would be like down here beneath where you can, the cutoff is.
And as we're finishing up questions, I'm going to release the last poll, the post survey, just to get things going, if that's all right with everyone. So as you guys answer questions, people can get those answers back in.
Okay. I see the next one is from George. He asked, does this generate a profit for the company? So OPPD isn't kind of a nonprofit by nature. So I don't have a direct answer to, does it generate a profit, because truly we don't generate profits. What I will say is the cost of it is competitive. You know, with market rates, it varies based on, you know, if something broke down, if we have to fix something special, but it's a cost competitive energy source. Next one is, what percentage of Nebraska's energy is methane related at this time? I don't have an answer to that, unless you got something, Mike.
I don't. I was just trying to look it up real quick. I mean, so there's basically 4 main generation facilities. LES has one at their Bluff Road landfill. Omaha has Missouri River resource facility, and we have a Papillion Creek resource facility, and then us at OPPD with the Elk Creek. There looks like it's about 95 million kilowatt hours last year. I have no idea what the total Nebraska generation is, but I would say there's not a lot of these biomass or landfill gas projects out there, so I would guess it'd be a very small percentage. I know Elk Creek is, like Justin was showing on that chart, 6 megawatts of capacity versus whatever the total was, 2,700 or 2,600. It's a very small percent. So I would expect the rest of the state to be similar.
And I don't know exactly what LES stands for Lincoln Electric System, what their size is. I know it's smaller than what Elk City is. And just anecdotally from talking with Waste Management, they also have the Sarpy County landfill, you know, over by Springfield. If you go back to Mike's slide, what they do there is they will treat it and compress the gas and then inject it right into the pipeline. And it just flows with the rest of the natural gas being served to Black Hills Energy customers.
What I could find from that is from 2020 to 2021, it increased by about 1.7%. So it's perfect, but it's a very small percentage of the energy.
It's a small percentage, but I'd say it provides a lot of value because, you know, going back to the greenhouse gas aspect, you know, I would, if this has a pretty bad greenhouse gas effect from letting methane, you know, escape into the atmosphere, being able to combust that and get something useful out of it is just a great thing, right? Because otherwise the answer is just to flare it. we're getting somewhere between 1,000 to 4,000 homes worth of power by consuming a gas that otherwise would be flared. So overall, I think it's a great project, and it's served OPPD really well over the last couple decades. Oh, let's see, what does that one say? Oh, never mind.
Yeah,
Alright,
we
well,
got another one. Looks like,
yeah.
do we expect methane energy to increase through the U.S.? So that's a great question. I would say yes. So there's many types or different types, I would say, of methane energy. Not all of them are this landfill gas. One of the topics near and dear to my heart that I researched working on one of my degrees was biogas through anaerobic digestion. So there's another way to produce this where they actually make these digesters. Basically, you input this feedstock of particular types, be it similar materials to landfill gas or other. Lots of research being done there, and they produce this biogas, which it's basically the same thing. They just call it something differently because it's not produced by a landfill. They're a great way to generate electricity, especially here in the Midwest. I know Iowa's doing a lot of looking at it because you can use leftover, basically leftover corn, stover type material or stuff that we have readily available here in the Midwest. It's just, the technology is fairly simple, but it's just getting these projects started, popularizing them, getting people motivated. In my opinion, Mike's opinion as an alternative energy specialist, I would say yes. I will see. I think we're going to see more of these projects come online. I think we're going to see more people jump into it once they figure out, like Justin says, the value. And these can be very valuable depending on where you put them, what kind of materials you had to use, and they don't only produce value in the energy. They produce the value of for the environment, where we're taking potentially harmful materials out of the environment and using them for something positive. So in my opinion, I would say yes, we're going to see this increase. It'll probably be slow, but especially with all of the decarbonization goals that the companies have, like OPPD, we're net zero by 2050 on carbon. This can play a piece in some of those goals. So hopefully that answers that question. Justin, if you want to add anything.
Mike, I think you did a pretty good job on that one. Recognize there's ultimately a limit, right, for methane production. I guess none of us want to just start seeing a dozen landfills the size of Pheasant Point in Douglas County, just sprouting up outside the metro area, right? So we're consciously trying to limit the amount of stuff that goes into a landfill. So you're never going to see 2,000 megawatts worth of landfill gas, or I don't really want to live in a place that has 2,000 megawatts worth of landfill gas.
And so Jaleesa and I are both on like the clean energy team for our program. And so we're doing work with the net zero goal. So I would agree with like the answer of methane coming in, because net zero for LES, like OPPD, MPPD that they've signed and are working for, it's just like taking the carbon that's already emitted and trying to even it out with clean energy. So methane would be a great contributor to that. Another question came in: can solar panels be placed on top of the old landfills?
Mike, you
Yeah,
take that one.
Yeah. Yeah, they definitely can. It's actually becoming more popular as landfills, are a brownfield site. Looking for ways to repurpose that land, solar is a great option. Now, we kind of looked at drilling into these caps for this technology, but solar, they're designed slightly differently. We don't want to penetrate through that cap. We use more of a ballasted system where it kind of just sits on top. But yeah, there's definitely a push for using that space. And I mean, these landfills are what, a couple acres to 10s, 20s, depending on how big they are. We can use that space and put solar on it for sure. So, and we're definitely seeing that out there as, again, these carbon goals are coming around. It's becoming more attractive. So something we're keeping an eye on here at OPPD.
Okay. Well, I think that's it for all the questions. If anyone has anything else, and Julissa, if you want to add anything.
No, I'd just like to thank Michael and Justin for being here and for giving this really interesting presentation. I know I learned a lot, so I think everyone learned some new information about methane in Elk City Station too.
It's not a big energy topic a lot of people know about, so it's very helpful. So thank you for coming in today. I guess not coming in, it's online still. Zooming in.
Thank you for listening.
Yes.
Sure.
All right. Well, if no one else has anything, I guess we'll call it a day. Yeah. Thank you for coming, guys.
Yeah. Thank you.
Bye. Bye,
Thank you.
everyone.